Hey guys, welcome to question MM232 of the Maths Methods Fortify study guide. So we've got this question. Farmer Liz has a rectangular paddock that she needs to partition with fencing for her animals as shown below. So we've got this big paddock and we're partitioning it into 4 equal sections, which is what's said in the next part. So Liz segments the paddock such that A1 equals A2 equals A3 equals A4, where A represents the area in meters squared of each segment. She has 800 meters of fencing available. So we know that there's 800 meters of fencing. That's important. Part A asks us to find an expression for H in terms of X. All right, awesome. So whenever we get given a question like this that gives us a set value for something, whether that's perimeter or volume or area, we're going to need to use that to relate these two variables together, okay? So what I mean by that is we know that we have 800 total meters of fencing, but let's figure out how we would actually work out what the total fencing is, right? So the total fencing would be this plus this plus this plus this, and then these 3 sections in the middle as well. So we know that the total is going to be equal to this bit here, which is X, then this bit here, which is also X, then this bit here, 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 and here, which is 5 lots of H, right? So 1, 2, 3, 4, 5, so plus 5H. Yep, so this is one length, and then we do that 5 times, which means that our total fencing length is going to be 2x plus 5h. We know that our total fencing is 800 meters, which means that this total fencing is 800. What are we looking for? We're looking for an expression for h in terms of x, which means all we need to do is find get h by itself in terms of x. So the way we do that is we get 800 take 2x equals 5h, which means that h is equal to 800 take 2x over 5. That's our first and only mark for this question. So that's the first part, that's your first mark. The key here is just always using the set value that you get given to find the relationship between those two. So let's move on to part B. Now, part B says that Farmer Liz wants to ensure that her animals in each segment have the maximum possible area to walk around in, which is pretty nice of her. Find the value of X which allows Farmer Liz to segment her paddock such that the total area of each segment is at a maximum, and state the maximum area of the whole paddock. Awesome. So there's a couple of parts to this, which is why it's a 3-mark question. But the biggest key here is our maximum possible area, okay? So again, and we've said this a couple of times through the differentiation section, whenever you see maximum area, maximum volume, maximum length, anything, we're going to need to find a general equation for that thing, so for the area, and then derive that and let it equal 0. So, first of all, we're going to need to find a generic equation for our area. So we know that our area of a rectangle, so the area of the whole paddock, is equal to x times h, which is length times width, right? Now, I know that it says the maximum area of each segment, but if each segment is at a maximum, that means that the total thing is going to be at a maximum as well. So we can just kind of, like, you could do it separately, but we're just going to do it x times h as the total area. So our area is x times h, but we can't find the maximum area of this because we've got 2 different variables, right? We've got x and h, which is why in the first question it asks us to find an expression for h in terms of x. So x times, we found that h was equal to 800 take 2x over 5. So whenever we've got stuff like this, we always want to get one in terms of the other so that we can have just one variable. From here, we get 800x take 2x squared over 5, right? So this is our area equation. We know that the maximum area occurs at dA dx equals 0, right? So let's find dA dx. So our dA dx is equal to, let's just get rid of this first. So if we separate this out, we get 160x take away 2x squared on 5, which means that our derivative is 160 minus 4x on 5. And that's our first mark right there. Now we know that this has to equal 0, which means 0 equals 160 minus 4x on 5. Rearranging this, we get x equals 200 meters, which is our second mark. You would obviously go into a little bit more detail than that, but this is fine for now. So that's your second mark. what we've found is the value of x, which allows her to segment the paddock such that the total area of each segment is at a maximum. But we haven't found that maximum area yet, right? So we've found the x value, but we haven't found the actual maximum area. So we said that the area was equal to 800x take 2x squared on 5. We know that x is equal to 200 meters, so we sub in 200 for x, and that's going to give us our maximum area. This is going to give us 160,000 minus 80,000 over 5, which is equal to 16,000 meters squared. And don't forget your meters squared as well, because we're dealing with area, so we have to include a unit. And this is our third mark. So guys, the biggest thing here is making sure that you let your gradient function equal 0, then find the value of x, and then actually subbing that back in to find the area, because if you don't do that, you won't get full marks. So that's pretty much it for part BI. Let's move on to part BII. Part BII asks us to find the dimensions of a single segment when the total area is at a maximum. Awesome. So a single segment is just one of these sections here, right? So a single segment, and keeping in mind that these are all equal, which means that their side lengths are all going to be equal. Because there's 4 of these, a side length of one of them is going to be x over 4, right? The whole thing is x, so a quarter of it is x on 4, and it's still going to be a length of h. So we know that its length, or h, is equal to 800 minus 2x over 5. And we know that our x value is 200, right? Because at the maximum of the total, at the maximum total area of the segment, the x value is 200. So 800 minus 2 times 200 over 5, and this gives us 80 meters. And our width, so our length is 80 meters, because remember we're after dimensions, so we need to be really specific about the way we word this. And our width is equal to x on 4, which is equal to 200 over 4, which equals 50. So our width is equal to 50 meters. And this is just a 1 mark question, guys. So that's our first and final mark. So biggest thing is just making sure that you segment these out properly and make sure that you got x on 4. That's part BII. Let's move on to part C. So part CI tells us, Liz keeps her pigs in the first segment of her paddock. She measures the hunger levels of her pigs to determine when to put more food in their trough. An adult pig's hunger over a half day is measured by how many kilograms of food, F, it could comfortably eat at T hours after 6 a.m, where F equals 10T e to the negative T on 2 plus 3. We have the graph of F as well. So C tells us a pig's hunger level is doubling at T equals A. Find the value of A corrected 2 decimal places. Awesome. So, do we have our CAS here? Yes, we do. Awesome. So, the key here is that if a pig's hunger level is doubling, that means that the gradient of its hunger is 2, right? It's doubling, so the gradient is 2. So therefore, f dash of t is equal to 2, okay? But we need to find f dash of t first. So, or f df dt, whatever you want to write it as. So if we want to find our gradient function of this, which is what we need to find this, then we need to recognize that this is a product function, right? So we've got 10t multiplied by e to the negative t on 2 plus 3, yep? So for our product rule, we let f equal u times v, and this positive 3 we can kind of just discount because when we derive this, that's just going to turn to 0, so we don't really need to include it in this product rule thing. So we let f equal u times v, where u equals 10t and v equals negative, e to the negative t on 2. So wait, f dash of t, or df dt, whatever, equals u times dv dt, plus v times du dt. Cool. So our u is 10t, and our dv dt is equal to negative 1/2 e to the negative 2t. So negative 1/2 e to the negative 2t on 2, plus v, which is e to the negative t on 2 times du dt, which is 10. Sweet. So from here we get 10e to the negative t on 2 minus 5t e to the negative t on 2. Fantastic. Which means that f dash of t is equal to, just taking out a common factor, 5e to the negative t on 2 outside of 2 minus t. And that's your first mark. So finding f dash of t is our first mark, and then recognizing that our hunger is doubling at this point means that our gradient is 2. So 2 equals 5e to the negative t on 2. Outside of 2 take t. And remember we have our cas, so we can solve this in our calculator. And our next line of working would be solve in cas. So I would literally write this, solve in cas, t equals 1.25. But we're not asking for t, we've been asked to find a. So therefore, a is equal to 1.25, correct to 2 decimal places, which means that's our second and final mark for part CI. And that's our final answer. So if you have any questions, as always, hit me up in the comments below. But let's move on to part CII. Part CI is a 1-mark question, and we are asked to find the time at which the pig is most hungry. Right, so this is 1 mark, and it's most hungry, as in its hunger levels are the biggest, or the strongest, at our maximum, which is point M here, right? So we know that from our previous question, f dash of t is equal to 5e to the negative t on 2 times 2 take e. And our maximum occurs when the gradient is 0, right? So 0 is our gradient, which means that 0 equals 5e negative t on 2 outside of 2 take t. So therefore, 5e to the negative t on 2 equals 0, and 2 minus t equals 0. Cool. This is not possible, so this is not an answer, not possible. So therefore, t equals 2. And that's our final answer. So, well, it's our second last step before the final answer. So the thing here is that the question asks for at what time is a pig most hungry, not at what value of t, right? So our value of t represents time after 6 a.m., which means that it's most hungry at 8 a.m., right? Because if t equals 2, that's 2 hours after 6 a.m., which is 8 a.m. So this is our final answer. That's our 1 mark. So just be really, really careful about that, because that tripped me up just then when I started to write that. So just be really careful about that. Awesome. Let's move on to part D. Now part D says, so it's a 2-mark question, and it says, for how long is a pig so hungry that it could comfortably eat more than 8 kilograms of food? So if it can eat more than 8 kilograms of food, that means that f, or f of t, is above 8, right? So let's say that at this point, that's like 8. I don't know exactly where it is, but let's just say for argument's sake, that's where it is. It's 8 here, which means that this time in between here is where it's more hungry than it could eat 8 kilograms, right? So our time from here to here is the amount of time that it's more than it's hungry as eating 8 kilograms. Sorry. So we need to figure out where this occurs, right? So if we know that f is equal to 8, that means that 8 equals 10t e to the negative t on 2 plus 3. From here, we can basically kind of get it down to 1/2 equals t e to the negative t on 2. And this is where our cas comes in, so you will not be able to do this by hand. If you ever have it x or t or whatever outside and inside an exponential, you're going to need to use your calculator. So solving cas, we get t equals 0.715 and t equals 4.307. And it's our first mark, right? We want to find the time above these points, right? We want this time in between here, which means that to figure that out, we get our time is equal to 4.307 minus 0.715, which is 3.591 hours. Yep, which is all good. But we want our answer correct to the nearest minute. So in order to do that, we need to grab our decimal of our hours and multiply it by 60 to get our minutes, right? So minutes is equal to 0.591 times 60, right? Because here we've got 0.591 of an hour on top of that 3. So what this gives us is 35 minutes, which means that it's above 8 kilograms for 3 hours, 35 minutes. And that's our second mark. So that's our final answer for part D. Let's move on to part E. Now part E starts talking about piglets. Very cute, which is a 1 mark question. So it should be quite straightforward, but it's a little bit different to what we've done before. So we know that from this question, a piglet's hunger over a half day is given by G of t equals f of t over 2 over 3 minus 1/2. Awesome. And we need to find an expression for G of t. So guys, the easiest way to do this would be to actually define this in your CAS. So what you would do is you would type 10t or x or whatever, t on 2 plus 3, and then you would click Control var, which gives you a little arrow button. So it's like on the calc, it's like STO arrow. That's the button you want to click, and then you type F bracket T bracket, click enter, and it'll say done. Or do something like this. Then what you want to do is actually just type this into your CAS. So you would then type F of T on 2 divided by 3 minus 1/2, click enter, and it will give you the answer. So it will give you G of t there, which is then G of t equals 5 over 3 t e to the negative t on 4 plus 1/2, right? Basically what we're doing here is we're getting our f of t, we're subbing t on 2 in for all of our values of t, and then we're actually dividing that by 3 and then minusing 1/2 from it. So this is our final answer. That's 1 mark, and that's it for MM232. If you have any questions, as always guys, hit me up in the comments below, but otherwise thanks for watching, and see you in the next video.